Hi everyone, in this video we'll talk about the concept of t-test and z-test for proportions. First topic, t-test. In our previous videos we talked about hypothesis testing, and in those hypothesis testing examples what we did was using z-table to get the critical value for us to compare the critical value to. But that assumption we used to for us to be able to use z-table or z-score is based on we know the population standard deviation. Okay, so before we did, let's just say it was z-test. Right, z-test, where we use z-tables and z-scores, right? And the base for that was, if we look at our test statistics, the formula was x bar minus mu h naught, is the mu under the null hypothesis divided by the standard error. And the formula we used for the standard error was standard error equals to sigma divided by square root of n, which is the sample size. And here we assumed we know the population standard deviation. Right? So this is the same as what we did when we learned how to construct confidence interval. We first assume that we know the population standard deviation, but in real life, we don't know this, right? In real life, we don't know the population standard deviation. Okay, so in real life, we usually don't know the population standard deviation, and therefore we have to do an estimation, right? So we have to use sigma hat to estimate sigma, and then the formula we used was sigma hat equals to the square root of summation xi minus the sample mean squared over n minus 1, right? This is the same formula we learned when we talk about descriptive statistics. Okay, so next is how we're going to use this one, this estimated standard deviation, and plug back into the formula here. So since now we estimate our population standard deviation using our sample version, so now what we have is t-test. Okay, now we have t-test, and then for the t-test, the test statistics stays the same. Test statistics stays the same, equals to your sample mean minus mu h naught divided by your standard error. However, now your standard error becomes sigma hat divided by square root of n. And in fact, this is the only difference if you look at your test statistics, right? This is the only difference. It's now we're using estimated version of your population standard deviation. And then now, because we don't know the population standard deviation and we're doing an estimation, now you cannot use your z-table. Instead, you have to use your t-table. Okay, so if you have to use your t-table, and then one thing you have to be careful is the degree of freedom. So degree of freedom, when you use your t-table, it's your sample size minus 1. So degree of freedom is n minus 1. So compared to z-test, this part is the difference, and using the t-table is another difference. So if you know the population standard deviation, you'll do the z-test or use the z-table. If you don't know the population standard deviation and you have to estimate it, then you're going to use your t-test and t-table. Okay, so that's the only difference. Now let me do an example to demonstrate to you how you would apply t-test. Okay, so this example, so we know that on Facebook, average friends number. So on average, people have has 338 friends on average. They have 338 friends, and in this case, we assume that we don't know the population standard deviation, right? So we don't know it, and then we're going to ask the question whether Cal State Los Angeles students, whether they have more friends or not. So the question, or what we want to test is whether Cal State LA students have more friends. Okay, so here we are doing a one-sided test because it asks the question whether more friends, right? So we're doing a one-sided test. And then let me just quickly write down the null hypothesis, mu less or equals to 338, and then the alternative is mu greater than 338, right? So what makes a difference when it's more than 338? It's the time that we see a difference. Okay, so what are we going to do? Now the one thing that what we're seeing is that this part is missing. So right away, you spot that we do a t-test. Okay. Now we go out and sample 5 students. We take a sample of 5 students and then record how many friends they have. 320, 332, 350, 400, and 413. Okay, 5 students and how many friends they have on Facebook, and then average equals to 363. That's our sample mean here. Okay, so what we want to do here, let's say we want to do our significance level equals to 10% or 0.1. So what we're doing, if we look at the standardized normal, what we're doing is say zeros in the middle. We want to test the right hand side because what makes the difference is when they have more friends than the average friends. So we're looking at the right hand side and we need this critical value, and the area here is 0.1. Okay, so let's see, do we want to do it? Yes. In this case, we want to use our t-table with degree of freedom 5 minus 1, right? So we have 5 sample points minus 1, this equals to 4. So degree of freedom is 4, and if we get that number from the t-table, this will give us 1.533. Okay, cool. So we have the critical value ready. We just need to calculate the test statistics. Okay. So test statistics equals to our sample mean 363 minus 338 over the standard error, which is sigma hat, divided by square root of 5. Okay, so we need this value here. We need the estimated population standard deviation. So let's do this. So just following the formula, sigma hat equals to 320. The first value, subtract the mean squared plus 332 minus 363. Okay, then continue. 350 minus 3 square plus 400 minus 363 square plus 413 minus 363, right? So basically we're just following the formula, taking every single sample point, subtract the mean, square them, add them up, and the whole thing is going to be divided by 5 minus 1, so n minus 1. Take the square root of the whole thing, and that's going to give us 41.376. 41.376 is the estimated standard deviation here. Now let's fill in the value to here and see what's the number that we get. Okay, so test statistics. Test stats equals to 363 minus 338 divided by 41.376 divided by square root 5, and that's equals to 1.351. Okay, and that's our test statistics. Then we do the same thing as what we did in our z-test. We compared this value to our critical value. In this case, our test stats is less than our critical value. So our test statistics is less than our critical value, right? It's 1.351, it's less than 1.533. So we failed to reject the null hypothesis, right? Because the t-stat or the test statistics is less than the critical value. The conclusion is we're gonna fail to reject our null hypothesis. Then the conclusion is our students not likely to have more friends on Facebook. Okay, so because we cannot reject the null, right? And the null says they're the same, so the null is kind of what we are accepting here. Well, not accepting, right? So again, this is the mistake that we make is we've failed to reject the null. Doesn't mean that we accept the null. It's just that we cannot show the null is false. Okay, so in this case, our students not likely to have more friends on Facebook. Okay, very good. And this is t-test. And next, I want to talk about when you want to do testing for proportions. Okay, so the next topic is z-test for proportions. Okay, so again, proportions is the how many percent of something, and what's the ratio, what's the percentage something happens or turn out to be one group compared to another. And let me just go ahead and give you an example to do this, right? So the concept is the same, but then instead of checking for values, we're checking at proportions. Okay. So let's ask the question, proportions of California Republicans, right? Okay, so how many percent of the California residents are Republicans? And let's ask the question whether it's 20%, right? Whether it's 0.2 or not. Whether P, again, P denotes the population proportion, whether P is 0.2. So our null hypothesis would be yes, it is. And then the alternative, P is not equals to 0.2. Okay. And next, how we are going to do this? Let's pick a sample. So we're going to ask 50 people, whether you're Republicans or not, and then 5 said yes. Okay. So of the 50 people in our sample, 5 said yes, they're Republicans. So if that's the case, then our sample proportion, that's what we did before, we can do that's hat, it's 5 divided by 50 equals to 0.1, okay? So 0.1 is our p hat here. Perfect. Let me give you the formula for the test statistics. Okay, so the test statistics. Okay, so this one also a bit different than what we had before. So this equals to our p hat minus p, the proportion under the null hypothesis, divided by your standard error, where your standard error, maybe rewrite this, equals to p under the null hypothesis times 1 minus p under the null hypothesis divided by n, and then you're going to take the square root of it. Okay, so this formula looks kind of different than what we used for z-test and t-test. Okay, but this is the standard error. Let me write this down here. Okay, and for proportions testing, we always use z-test. So always do z-test, which means that you always check your z-table for critical values. Okay, perfect. And that's good. So let's do the test. Okay, so let's say we assume that our alpha is 0.01, right? So our significance level, let's make it 1%. Then what we're looking at is the distribution like this, 0, and then, right? We're doing two-sided test because we want to see whether it's more than 0.2 or less than 0.2. So if the middle is, no, the two tails, they add up to the significance level. So here we have 0.005, here we should have 0.005, and then the critical value we are looking at are 2.576 minus 2.576. Okay, we have the critical value ready, and let's do the test statistics. Okay, test statistics equals to our p hat, 0.1 minus 0.2 is the one that we're testing, and over 0.2 times 1 minus 0.2, which is 0.8, and then divided by 50, our sample size. And this equals to minus 1.77, and that's our test statistics. And now we're gonna do the comparison. We're gonna compare the test statistics with the critical value. Okay, our test stats in absolute value is 1.77, and our critical value in absolute value is 2.576. We're going to compare these two values. We see our test stats, it's less than our critical value, right? So this one's smaller than the critical value. The conclusion that we have failed to reject the null hypothesis, right? We failed to reject the null hypothesis means that the null hypothesis might be true. So the conclusion is likely there are 20% of California residents are Republicans. Okay? Because we failed to reject enough. So the no might be true, or likely it's true. Okay? So this is an example how you do z-test for proportions. Good. In this video, we talked about the concept of t-test and z-test for proportions. Thank you for watching. I'll see you in the next video.